Hi, can everybody hear me?
Hello, hello. Can you hear me?
Awesome.
Yep.
Yeah, I can hear you now.
Hey
All
there.
right.
Great.
Great. Welcome, everybody. It's great to have you all here. I'm really excited about this conversation today. Because think about 2024, the decentralized AI network BitTensor had to halt its own blockchain after attacker drained millions from community wallet that same year. Another AI-focused marketplace that is IO.net faced a breach where attackers manipulated GPU metadata through a simple SQL injection. Two very
Wow.
different systems, right? One securing the value in the centralized machine learning network, and the other coordinating compute for AI training. And both of them were hit by exploits that weren't flaws in the artificial intelligence itself, right? But in the trust fabric that surrounds it. And that's the paradox we're here to explore today because, as we all know, AI is hungry for data and compute, and blockchain promises you trust and coordination of your data. But when you fuse those two together, you don't just get innovation, right? You're also expanding the attack surface. So the real question is not just about what we can build with AI and blockchain together. It's also about how do we secure the new foundation of intelligence and value before someone else break them. Because somewhere between AI's appetite for everything, right, and Web3 dream of owning nothing might be the future of digital freedom. My name is Stephen Ajayi, and I'm going to be your moderator today. And my role normally revolve around carrying out security audits around Web2, Web3 integration, and also the AI security audits at Hacking. But for the next hour, my job is to guide this conversation. And this one is going to be all different. That's our audience because we're going to be looking into the lens of what happens when AI meets blockchain. And why security is not just another box you have to tick, but should be the backbone that determines whether this intersection is going to last or not. And I'm very excited because I'm glad to be joined by some brilliant mind across the Web3 space, from Near, Coranium, and Secret Lab, and also Next Encrypt. So instead of me telling the audience about your LinkedIn bio, could each of you briefly introduce yourself to the audience, share what you're working on right now, and why it matters in the AI blockchain moment? Let's start with Ethan from Let's Encrypt.
Sure. Ethan, yeah, I have a consulting company, Next Encrypt InfoSec. I'm in the New York area and do fractional chief information security consulting and advising work. In the past, before the last couple of years of doing that, I've done work full time as in roles like being the chief information security officer at Galaxy. I've also done some TradFi related crypto work at places like Citadel Securities and Bank of New York Mellon. You go back even further, I was at Bridgewater for about 8 years, last decade. So lots of time in finance, and at this point, it's turned into even more in crypto.
Oh, nice. Nice to meet you, Ethan. Kapil?
Hi, Stephen. Hi, everyone. Pleasure to be here on this panel today. Kapil Dhiman, I'm the CEO and co-founder of Uranium, building a quantum secure blockchain architecture. And the focus is to secure the movement of money. My journey has started as a tech consultant, then as a Web3 head for PwC, and then worked in the consulting space for quite some long time. Did a few startups, some worked, some failed, but fell in love with crypto in 2016. And since then, the journey has been all about Web3. Looking forward to our conversation today.
Thank you very much, Kapil. Shai?
Everybody, nice to meet you all. My name is Shai Pernick. I am a principal ecosystem solution architect at Near, which means I get the awesome responsibility of leading both our solution architecture and as well as our technical enablement. It means I get to work with our builders on a regular day-to-day basis and really understand what it is that they're building, what the roadmap is, where their challenges are, and then marrying them with the ecosystem. And then I lead a lot of our content development, our developer enablement, kind of the developer journey, the educational experience as well. And so I have the fortunate opportunity of being very much on the ground floor with a lot of our builders and understanding really what works and what doesn't work. A little bit of background on myself. I've been in IT for about 30 years now. Started back in 2000, right before 9/11. So I had the fortunate opportunity of being in IT for almost 30 years now, across many different spaces, all the way from Web 1, Web 2, and then building in Web 3. Before coming to Near, I was at Amazon for about 6 years. I led solution architecture teams as well as go-to-market teams in a global tech leader role, and then led the Web3 and blockchain partner organization as well as the practice organization, and then went on to lead enablement at Polygon. Been a builder for my whole career, my whole life. I very much like building products, figuring out what works and what doesn't work, and so very excited to be here. Also have a very deep passion for security, and was a former CISO in my past career at AmeriGas Propane. So thank you very much for having me today, and excited to be part of the show.
Thank you very much. That's an awesome introduction. Alex, on to you, but we can't see you though. It seems your camera is off.
Yeah. I'll fix it a little bit later. So first of
Okay.
all, happy to be here. Thanks for having me. I'm CEO of Secret Labs, the developer of Secret Network. Secret Network was the first confidential computing mainnet chain, starting about 5 years ago, based on TE technology. And we have relatively recently, about a year ago, ventured into the confidential AI space using the same TE technology. My background is in software development, product management, investment, and VC investment specifically. I joined the world of crypto in 2018 by heading Beam, which is a confidential currency. And about 2.5 years ago, I joined Secret Labs as CEO, and it's been an exciting ride, and especially all those new technologies, the AI and the marriage between AI and blockchain, that's all very exciting. So happy to be here and hear the thoughts of the panelists.
Thank you very much, Alex. All right, thank you all for that wonderful introduction. Before we dive deep into our chat, I would like us to loosen up a little bit. So I've got one quick warm-up questions for each of you. The first question is going to go to Kapil. Kapil, if your chain had its own AI agent, what would you make it do first on testnet?
Oh, that's a very interesting one. If my chain had my own, okay. I think it'll be more about, I would integrate it with our wallet. So we have QSafe, which is a quantum secure crypto wallet. And through that, spread awareness and education to the users who are using that wallet about the importance of security and what's happening around, so that they can take intelligent decisions about their money. That's what I would make the agent do, and evolve it into becoming a personal agent for each user, making people smarter with their money. I would make them do that.
Yeah, that's interesting. So Alex, you talk about Secret Lab being all about privacy. So what's one everyday application that you think would benefit from private AI?
Well, it's a great question. Actually, my stance is that any AI interaction should be confidential. As the time goes, we're sharing so much with AI, it's just unbelievable. We're sharing our work information. We're sharing our personal information. We're sharing all of our interests and our deepest thoughts and the toughest questions. And when we're using non-confidential services, all this information ends up in the vaults of, OpenAI or Anthropic or Gemini or any other big company, and that gives them immense, incredible power. And the way I like to put it is, before AI, they wanted and they got our data. And now they're getting much more. They're essentially getting our soul into their hands. Like, they know everything about us, and I think by now they know more about us than we do ourselves. And that's why I think the world should be moving to provably confidential AI, so that this information, which is immensely, immensely valuable, unbelievably valuable, this information does not end up in the hands of big corporations who are already starting to use it, and we'll be using it even more and more and more. And they are actually able to put thoughts in our heads, not just sell us stuff. So my stance is that we should all think of that, and we should all strive for confidential AI interactions so that our data remains ours and remains private.
That's very enlightening. We're still going to sort of dive deep into talking about privacy and why AI conversation should be more private and why organizations should actually put on strict rules on how we use AI. So, all right, on to you, Shai. Tell me, if you have an AI agent and it could take one chore off your dev flow this week, what would you hand over to it?
Yeah, this is a tough question because I think the challenge is always the way I think of it is like if I had a clone army, what would I sick my clone army on doing so that I can go and relax and be with my family? Uh, the
Take over the world.
yeah, I think from a developer mindset particularly, right? I think one thing is that as developers, we often play with the bleeding edge tech that is in this space. We're often trying to test out how do things work across multiple different product stacks, what works and what doesn't work. And I think we do a decent job as developers figuring out what works and what doesn't work. I don't think we do a good job in really educating the rest of the world on what we've learned and what we figured out, what breaks, what doesn't break, right? And get that information back to the product teams. And so when I look at the agentic workflows that I want to build, one of those is particularly almost like a product manager, developer cop, if you will, that is watching me develop, is then going and testing out the things that I work on, and then creating some educational material off of that to validate that development cycle. So did I put the right dependencies? Do I have the right descriptions in there? Create like a blog post, create a presentation off that, create some sample code, just so that way my own learning doesn't fall by the wayside, and I'm also educating and empowering others to do the same thing. And so that's something that I actively do that is very challenging. And I think the more of us that can do that as developers, we're going to help move the industry forward if we can help teach each other what we learn and what works and what doesn't work.
All right. Thank you very much, Shai. Ethan, you spent a career thinking about threats even before they happen. So here is your own version. If you have your own AI sidekick watching your back 24/7, more or less like a telemetry, what would you make it monitor first? Is it the people, is it the process, or is it the data?
That's a fun question. So there's a fundamental thing. I don't think we're at a point where AI can really actually watch my back. I think it can just be part of a bigger or better system, or a way of improving things to make that work in better, smarter, more efficient ways. There's the fun, if I'm involved in a company or that sort of thing kind of way of really I just got to look at what I proportionally need. Where are the needs, where what are the goals and objectives that aren't being met, and what actually makes sense as like a good fit. And then there's the basic fundamental side of that. I'd pick people. They're the most unpredictable, the most hard to really understand and get in front of in lots of ways. And AI might have some unique qualities it could bring to that. That tend to be a little easier, for at least for me. Where technology is almost always relatively easy to figure out. The people are just that much harder sometimes.
Yeah, thank you very much, Ethan. All right, that was a refreshing start, and I'm sure our listeners are also picking up some personality of your work from those answers. So let's kick off with something really simple. When we throw around the phrase the interaction or integration of AI and Web3, it sounds very big and exciting, but it also leaves people wondering where the AI actually sits in all of this. So this is what I want to know. In your project, where does AI actually sit? I will start with Shai. Nia has been talking about user-owned AI and also on-chain agent, right? What exactly is your user-owned AI, and exactly what is AI doing in the near ecosystem right now? Is it like a user tool or a developer framework or an embedded part of the system?
Yeah, no, so I really enjoyed that question, and it really hits home on why I came to Near, right? I fundamentally believe, and at Near we do this as well. we believe that humanity is at a hard fork moment. We really have to choose what it is that we own and what it is that we control. And AI is going to be that next generation, that key part of the next generation of the internet. It's not just about blockchain only. It's not about AI only. It's about blockchain and AI working together. And it's not going to be the only piece. They're going to be components of this next generation of the internet. It's also going to drive a paradigm shift of how we actually access data and why we like to say that the next generation of the internet is very much about user-owned data, user-owned AI. And so we believe that in the future, you're going to have much more agentic applications. That's how we're going to interact with the next generation of the internet, is through those agentic applications that will have on-chain extensions to them, whether they're extensions of the user, extensions of the agent, extensions of the underlying data. The AI and blockchain part will always go back together. And it's really a key part of a lot of things that we build in here. A lot of things are around AI. Fundamentally, we started off the company 5 years ago as an AI company and then realized, we do need an underlying blockchain layer. There's all these other components that you need in order to deliver AI at scale and really deliver decentralized AI. And so that's really what we're after, is this concept of decentralized AI, right? People owning their own data, people owning their own agents, not having it owned by a single state or by a single entity. And ultimately, you own the permissions of that AI. You own all the data around it, and it becomes your autonomous agent that really works on your behalf. It executes your requests, the things that you want to do. It can interact transactions on your behalf. It can move things across chains. It can interact with different apps on different chains. It can move assets across different chains. And so for us, we have all these pieces around the Near ecosystem in the stack, but AI is a really key part of what enables a lot of those different pieces that are there. And so I really urge listeners to think about, when they think about blockchain AI, to just kind of think that there's a lot more below the surface. And a lot of the companies that are here today talking about this stuff, we've been building this stuff for many, many years, and it's fairly complex. It's fairly challenging, but it will be the fundamental next layer of the internet.
Thank you very much, Shai. So, with what you said now, that means AI is not just sitting in the lab, it's actually part of the chain interaction layer. That's actually a big shift from AI as a service to AI as an infrastructure, don't you think?
Yeah, and it's very much AI as the presentation, right? Like AI is the infrastructure piece because it's how we will interact with the next generation of the internet, right? Not just
Hmm.
in the sense of using chatbots, not in the sense of just deploying web apps that we need, but ultimately the way that we interact with the internet, I believe, will fundamentally change over the next 2 or 3 years. The forums that we're used to, the chat interfaces that we're used to, the UI interfaces that we're used to, a lot of these things are going to change and start to be much more personalized and AI driven so that I can access the same content as my mom does, but she might read it in a different format, whereas I might read it in the format of Star Wars because that's what I'm interested in. And so I think that it's a key part is about the presentation layer of the internet. And to me, that's where the AI portion sits, particularly is in that presentation layer.
All right. Thank you very much, Shai. So another question that got me pondering is that this is actually directed to Alex, because Secret Lab is building confidential AI inside secure enclaves. Alex, how does that map into your stack? Does the call live inside the enclave itself, or is it next to other components, or does it act like a privacy layer around on-chain logic?
Yeah. So can you hear me well? Yeah, I just changed the device.
Yes, loud and clear.
Okay, great. Thank you. So in our case, the AI infrastructure is actually running off-chain, but it uses the chain for certain use cases, such as keeping the secret. So our AI is built on our more general confidential virtual machine technology, which we call Secret VM. That is an off-chain technology that utilizes secret network for things like payments and for things like keeping secrets, like the key management system. So the confidential virtual machines can keep their secrets, like passwords, API keys, and things like that. So the KMS is used for that. And we also use that for use the blockchain for developer credentials that are provisioned on our Secret AI portal. So the AI and secret VMs in general are cooperating with the blockchain for that purpose. So the technology again is off-chain, but it utilizes the power of the confidential computing blockchain to keep the secrets in a fully decentralized manner, in such a manner that they're not really available to anyone besides the actual developer. And same for our AI, right?
Okay, thank you very much for that clarification, Alex, because I actually thought it was an on-chain component. Kapil, this one is for you. Corinium describes itself as a convergence layer. Can you unpack what that means? Because it sounds like it goes pretty deep into the system plumbing. So in your design, does AI operate as, let me put it this way, as a native citizen of the chain, or does it work like a coordinating layer that drives the rest of the workflow?
In a way, both. So the way I've always looked at AI is primarily it is an application layer. It adds value to make something effective, but it is not the primary infrastructure, right? There has to be something on which AI will utilize to kind of make it efficient. Like take any example for that matter, right? For ChatGPT to work effectively, you have to have like a lot of data in place already, a lot of other things in place. Only then ChatGPT will work effectively. And I use that as an example because that has become a classic synonym for a lot of people when we talk about AI. And then OpenAI APIs are, now fueling a lot of other things as well. So the primary utility for any AI application has to be to make human lives more efficient. Now, when it comes to Corinium, we are doing it in two ways. Number one is we identified what is the biggest blocker for the blockchain industry right now. Why only less than 3% or 4% of the developers, the entire developer base, is looking at blockchain and rest are not even playing around with it. If you see, the reason is twofold. Number one, they have to learn a new language. And number two, the acceptance of blockchain projects, right? Developers go and build in a direction where they think the product can sell. So $4 trillion is the overall market cap of the blockchain industry right now. Banks like JP Morgan moved $8 trillion, $9 trillion in a day. We are celebrating $4 trillion, so which is an optimistic thing because we have a lot to grow on. But at the same time, it puts a question mark on what is it that we need to do differently to bring in mass adoption. We use that word a lot in blockchain, but how are we trying to solve it? The first and the foremost to break that bottleneck is, really motivating the developers to come and build and learn the whole world of blockchain. So we use blockchain. We use AI in the Corinium blockchain. First point of contact by this. So the smart contract deployer that we use is QRemix AI. It's a no-code smart contract developer and deployer and auditor as well. So even if you don't know how to code, by talking to that application, QRemix AI, you can build your entire smart contract, deploy it, get it audited. It will show you suggestions, and like within half an hour, you will have your smart contract ready. This gives a lot of motivation and like an entry barrier removed for many developers. And I'm talking about like the young developers here. The experienced one, of course, will have a lot of other things to play around with, but a lot of young developers, and we are starting to see that happen. We have done multiple hackathons on ground recently in a very casual way to colleges, and kind of got really optimistic responses testing this on the ground. So that's number one. Number two is if the overall scheme of the blockchain industry, if you see, the most important aspect for any application to be successful is smart contracts, right? So blockchain is decentralization, your private keys being yours, and smart contracts. Primarily, everything kind of moves around these three things. In the smart contracts, apart from the name, nothing else is smart, to be very honest, if you see so. It's the function of if and then. If this happens, then that happens. So what is exactly smart in those smart contracts in the current age? We are now, it's just 2 months away from 2026. What exactly is so smart that can move things faster? So what I've always believed is we don't need artificial intelligence for blockchain. We need adaptive intelligence. How can the smart contracts actually be so smart that they can learn and they can evolve and they can take further a lot of more decisions, right? So that's the next thing that we are implementing at the Corinium level, the smart contracts which are going to be deployed. At the infrastructure level, we are integrating AI to make sure that these smart contracts actually evolve, considering the dynamics that the developers are going to put forth in. So by doing these two things, we ensure that number one, the developers are motivated to enter and then stay as well. And even from a user point of view, they are getting a much intelligent ecosystem, which is then placed on a quantum secure blockchain. So your money is secure, your data is secure, while what you are building is ever evolving. That's how we create the whole convergence layer concept.
All right. Thank you very much for the clarification. So I have one more question for you, Kapil. So for QRemix, do you have your own proprietary model running, or are you subscribed to, let's say, enterprise APIs like OpenAI or Claude AI API, or are you using an open source model in the background for Remix, for QRemix rather?
A mix of both.
A mix, okay. All right, thank you very much. Ethan, you've been at the forefront of enterprise security as a chief information security officer. So, and you've definitely helped a lot of organizations harden their system from a security standpoint. From your perspective, when organizations plug AI into their critical system, where do you think it should live?
So this is the fun question. Well, one of the ways I really think of this is it's really about what you're trying to do and achieve with that AI system. You might have things that are meant to be, messy, sloppy, pulling from as much data as possible. And maybe you're really optimizing for speed and availability of those systems. In other cases, you may be doing something with AI that's very much back end. You want it to be very consistent. You want as little, volatility in what's happening as possible. And the ways you approach that really is depending on what those goals are. So it really depends on the type of solution you're building out. So something that's very isolated, you want to think about privileged access, how you're really hiding that thing away and protecting it and all the layers of, defense in depth for it. If you're getting a lot of value out of doing something public facing and agentic, completely different model because it's meant to be facing the outside world. It's meant to be interfaced with. And so it's really thinking through, what are those properties or qualities that you want to optimize, and then building an entire security plan design approach around that stuff. So that way you're thinking about, the entire ecosystem, the life cycle of it, all those good things.
All right. Thank you very much, Ethan, and you're very correct. So now we've talked about how where AI lives in your ecosystem and also how it fits into your stack. But here's another truth. Everything sounds elegant on paper until real users shows up. That's when the system just stopped from being just a concept to a real system. So how does that transition actually looks like for you? Was there a moment whereby you had to like rethink a design decision, or was everything great right from the onset? The floor is open. Shai, Alex, Kapil.
So the question is whether everything went smooth from the beginning and whether we had to
Yes.
change things.
Mhm.
Well, I think strategically we didn't have to change very much. The overall strategy of providing infrastructure for confidential computing and specifically for confidential AI is very clear, and it's staying. Now, tactically, there are a lot of different technical decisions that we had to take, starting with, which service to use for generating SSL certificates in our virtual machines, and we had to switch in because of various reasons, down to how exactly we're using, say, the key management service and what is the required functionality of that contract that also had to be updated, and it will actually keep evolving as we work with more customers, as we work with more use cases. What are the functionalities that are required from the system? We have relatively recently introduced a very interesting functionality we call verifiable message signing, whereby our confidential VM or our confidential AI can actually sign a message and create a proof that this particular message was generated by this particular workload. And it turned out to be a very powerful feature, which we hadn't thought about in the beginning. So my answer is the strategy remains, but the tactical and technical decisions constantly evolve. And I think it would be true for almost any project, right? It never happens that everything right from the start, and that's why software development and software architecture is such a complex and an exciting task, because things always change, always evolve, and you have to adapt to the market and to your customers and to the new technologies that arrive.
Thank you very much, Alex. Shai, Kapil, do you guys have something to add?
Yeah, I think I can jump in with something that I see pretty often, right? When builders that we work with go from production or from that demo environment to the production, and I've seen this both at many layer ones I've been part of, it's really about that scale of what you're able to do, right? So do you have the security controls in place? Particularly when we look at AI models, are you using, I'll say the right models, but it's more about the cost, particularly. Are you getting the kind of expected performance that you're expecting from that model? Is it under the cost that you're expecting? And so that's one of the things that I found very challenging for a lot of builders that come into the AI space, particularly from the blockchain side, is that they're not used to paying the inference costs and the multiple attempts and reiterations that sometimes it takes when you're moving from that demo use case into production and really trying to establish that scale. And so that's something that I always try to recommend, that when you're in that demo stage, you're in the very early onset of your application, you're building out. Think about, what does that scale look like? What is your current cost today? What does your current user demands look like? And try your best to extrapolate that out to better understand your actual cost modeling. And are you getting the right performance that you need from your models? And then also, how do you have that upgrade path so that when new models or new cost measures come up, you can take advantage of those? It's never a one-way door. It's very much a concept of a two-way door. And how do you adjust and change that architecture as you continue building? So I don't think you're ever really done moving from demo to production. You kind of just move from demo to production, and then you reiterate in production and keep building and keep building. And you always have to think about that architecture and the infrastructure and how do you achieve that scale.
Thank you very much, Shai. Kapil, do you want to add something?
Could you reframe the question for me, please? What was the
Yes.
question again?
Yeah, so the question is, when you moved from demo to production, was everything great right from the box, or did you have to rethink a design decision?
Oh, always. I think it's never what you plan exactly. It always
Yeah.
evolves. So I think I'll keep my answer short there. Never, and not just in AI, blockchain, or ever, any product you build, you would have in your mind something else, but when you start building, something different comes out. And that's the key, to have that flexibility. Even what we are building, multiple times, multiple times, we have evolved. We initially even had a proof of work blockchain, like the massive one, if I can speak about our own experience. Last December, we launched a proof of work blockchain. On the architecture side, to scale, we had a specific thing in mind. The way we wanted to scale, we moved to proof of stake, and now we are on top of it building a block DAG model. So that's a classic example of, even from our initial thought of building the way we wanted to build, we solved one, but then we realized that you need to have that kind of flexibility. We still have that proof of work blockchain, by the way, which we use internally for research purposes. But for the public piece, we moved to proof of stake. So it's always the case. And I think that's what makes the building journey interesting as well, to allow yourself to be flexible.
Yeah, correct. Thank you very much. Now, let's move on to what I know is top of mind for many of our audience: security and privacy. So here's the first one for you, Alex. Secret AI is all about running model inside a confidential compute so that they can process sensitive data without leaking it. So how do you keep this prompt and output private while you're still allowing other systems to build on top of it? Because we all know that Web3 is composable. You need a lot of information when it comes to Web3, and you can't just lock everything in a black box. So how does that actually work in your ecosystem?
Okay. That's a great question. And that's a question that pertains to the confidential virtual machines in general. So the confidential virtual machines, they have two key properties. One is privacy, and it's a very simple property. And the only thing it means is that the owner of the hardware doesn't have any way to look into the memory of the confidential virtual machine. Okay, so you can run your confidential virtual machine on my hardware and be sure that I cannot peek into the memory of your VM. It is not true if the virtual machine is not confidential. So if you're running a VM on a Google machine, Google, if they wanted to, they can get to all your data because the memory is not encrypted and the owner, the root user of the machine, can access it if they wanted to. Okay, so this is the first property, but it's not enough. The second property makes the system complete. The second property is verifiability. And that means that I can prove to you exactly which workload, meaning which source code is actually running on my confidential virtual machine. And then you can examine the source code and see that it's not saving your, let's say, your prompts, if we're talking about an AI service, that it's not forwarding your prompts anywhere. And I can prove to you that this particular machine you're talking to now is running that version of the code. And in the code, you can see that your data is not being shared. So it's not based on my promises. Like, OpenAI might tell you, hey, guys, we're not really saving your data. We're not using it. But how can you verify that? No way. You just have to believe them. And we know we should believe anyone in those matters. So with confidential virtual machines, that becomes trusted. So code kind of becomes law, meaning that I can prove to you what I'm running here. It in a lot of ways like a smart contract, right? Like a smart contract on a blockchain, you can see the source code. So then you can trust that that smart contract. So these are the two key properties. Now, those in the case of confidential AI, those properties, they protect data from whoever is running the system. So if I am currently offering confidential AI to end users, their data is protected from me. Okay. Now, if they're using a third-party agent that's not running inside a confidential virtual machine, then that agent could still get access to their data. Okay, that's why we're also offering this confidential VM service where you can run any agent in a confidential virtual machine as well. And the ideal solution to me is a chain where whatever agents are running are all running confidential VMs, and whatever AI services are running, whatever LLMs those agents are using are also running inside confidential VMs. And that way the data remains private all the way, and anyone who wishes to do so can verify the source code and see that the source code is doing only what it's supposed to do, and it's not sending this information anywhere. Same way as you can look at a Uniswap smart contract, like the Uniswap, V2 or V3 pool, and you can see that it's not like stealing your money, and it's not, taking some part and putting it in somebody else's pocket. That's why you trust it. So this is the model. So in order for the system to be private and secure end-to-end, it's desirable that all the elements of your AI system, including your agents, including your front ends and back ends, all of that are running in confidential VMs. Actually, we are now working on a medical AI application, which has a front end and a back end where people can upload their radiography images. And it also has agents running as part of the big agent ecosystem. And all those elements are talking to confidential AI services, and all of those elements are running inside confidential VMs. And that's why this super valuable and super private medical information remains protected all the way through. So just to stress, it's not enough to just use a confidential LLM or an LLM running in a confidential virtual machine. Any and every piece of software that gets access to confidential data must have those properties. It must be private, confidential, and verifiable.
Thank you very much, Alex, for that insight. Shai, so this one is for you. Nia has been exploring the concept of proof of response, which I think is a way of is a cryptographic way to guarantee that a decentralized service like an AI agent actually replies when it's supposed to be. So my question is, what kind of on-chain verification or cryptographic layer will make that trust scalable?
Yeah, that definitely makes sense. So I want to give first a shout out. I'm gonna take this in a different direction, because Alex actually covered a very key part of the verifiability, the code is law, the privacy preserving piece. Those are all like fundamental key pieces that we have to have, and that the industry is working on, and something that we need to develop, right? And it's very close to my heart because I've worked on things like Nitro Enclaves and the deployment of that into the ecosystem many years ago. But I think when we think about AI and we think about security particularly, what we also need to think about is composability, right? How do we use that component in many other things and build on top of it and use it in other ways in the future? And a key part of composability is liveliness. And the paper that you're referring to was written back in February by Ilya and Alex, the two founders of Near. That's the proof of response paper that was written back in February. And that talks all about liveliness, right? And the whole goal is that you can't build a reliable system if ultimately you can't prove that liveness. Your agents are going to depend on each other and are going to depend on humans in the loop as well. And if any of those agents are offline or they're not responding the way that they're supposed to be, then how do you have an economic layer? And that's what the paper explores, is creating this economic layer that sits on top so that as the dependencies grow of these AI networks, we ultimately start to address these problems early on, just like we have dependency problems today with software packages. And so that economic layer is very important, right? It sits on top of the chain itself. It's for managing any of the requests or messaging. You're guaranteeing really three things, and that's what the paper explores. One is that you have valid and assigned response from your AI agent within that time frame that you expect it to respond by. If you don't, then there's going to be a proof that that agent failed to respond. And if it failed to respond, then there's going to be some sort of on-chain economic penalty to deter them from failing to respond in the future. And the other way is also ensuring that there's a streaming payment option between multiple agents, whether it's to pay for monetization service because that agent is live, it responded when it was supposed to be, or because there was a penalty and that agent wasn't able to respond when it was supposed to pay, when it was supposed to respond, and therefore it has to pay a penalty. So what this system does is it creates a set of economic guarantees that are backed by the underlying smart contracts that exist on chain to ensure that those agents are alive and responding. It creates that certainty that we need as developers so that we can make sure that the agents are not only online, but they are provable, as Alex was talking about, that they're verifiable, as he was talking about, and we can confirm that outcome. And so we can't kind of do any of those things if we can't prove that underlying liveliness and making sure that the service worked, that it's up and running, and we have that cryptographic proof of that network communication and that cryptographic proof of that response, or the cryptographic proof of the lack of response. To me, those are all fundamental pieces that we need in order to create this composable and secure layer that we're talking about. And that's what the proof of response paper that you're talking about explores.
Thank you very much, Shai. Ethan, so let's talk about security a little bit. How do you think about AI model as an attack surface? And then what is the right way to defend against somebody actually maliciously injecting malicious data into data upstream?
Good question. So one thing that's sort of related to this, I'll mention first. I see sort of a pattern or trend with history that's probably going to repeat itself. And this goes into a little bit more of like less the poisoning and just the integrity of systems and the maintenance of them. If you look at, decades ago, you had, RDBMSs or relational database systems coming out, and then you had, database administrators as its own specialized expertise. A while after that, you had like analytics and data scientists picking up, and then you had a lot of expertise around how you get those systems working, how you work with them. I think we're already seeing it to some degree, but over time, I think it's going to turn into that sort of level of specialized profession to be able to build and maintain and help keep those sorts of systems organized, in the AI world. So it's something that I'm just sort of anticipating. Could be wrong, totally fine. But I would be very, wouldn't be surprised at all if it picks up in that sort of way. Even with that doesn't really do everything. It's just, it turns into, somebody being a lot more specialized and being, attuned to how they think about the integrity of that stuff. Separate from that, the high level, going back to, the like having good designs that can avoid problems going in from the beginning is one of those keys. And then I sort of like thinking about the sort of the framing of like maintenance, data controls, monitoring. The maintenance, a lot of it's going to be these sort of unsexy, disciplined things that need to happen with your systems. And it's not that special about AI, but it's just, are you actually running change management? Do you have real oversight of this stuff? There are going to be nuances about what AI will do, but at some level, just like other technology, you need to be really carefully watching what's going on, monitoring it, managing it, looking for, when things are changing or when things are going in ways you're not expecting. There's drifting and things like that can happen AI or non-AI. There's also some other fun areas of, how do you test it? How do you get ready for that? You can take that to some more extremes, knowing that it's designed to not be very, deterministic or, entirely predictable. Think about like pen testing, red teaming. There's all kinds of directions you can take those sorts of things. Other areas, when you're diving into like data controls, what data are you using? Are you using your organization's internal data? Well, do you have good data classification? Do you have data inventory? Is it organized? How do you know what's actually going into it? There's a whole data quality arm even. If you're trying to carefully worry about what goes into it, there's could it be poisoned or is it just bad data to begin with? How do you even think about organizing it and getting better control of it? Within that area also, some of the areas of things like privileged access related to the data going in and the AI system itself. Again, change control or change management. How well is this organized? And that really feeds into, that high level thing that we were talking about before. What are those dependencies that we're really worried about? Is somebody putting bad data into this the biggest threat? And if so, yeah, you really want to think about that in a comprehensive, disciplined way. The other piece of this, just to hop into, the monitoring is, as it's going, it's meant to be unpredictable. It's meant to sort of drift over time, and we've seen lots of this over the last few years. Stay on top of it. Get creative about how you're doing that. Maybe you have to do certain things manually, and maybe that's where you don't get as much lift, but that's where you get more control. Or maybe you can creatively automate more ways to stay on top of AI. Maybe you're having one AI watch another AI and tell you what when something's going off the rails. It's really getting creative about what you're doing to be able to find that efficiency and that value overall relative to those other sort of qualities that you need in terms of integrity and capability.
All right. Thank you very much, Ethan. So from what you said, it's not about just focusing on one part of security. It's more or less like an end-to-end security, more or less like a defense in-depth security, the overall security of the whole infrastructure, not just focus on one particular aspect of the infrastructure.
Absolutely. And the more critical the dependency or the need or the quality that you need out of it, the more you want to think about that too.
All right. Thank you very much, Ethan. All right. Let's shift this conversation into governance and trust, because here's the thing: if AI is running around on Web3, this question is definitely going to show up at the end of the day. Who is actually in charge? And it's one thing when an agent is helping teams with, let's say, development chores and summarizing data and whatnot. But once it starts touching governance, proposal, wallet, vault, treasuries, and so on and so forth, the stake is going to get way higher. Now, my question here is to Kapil. Your project talks about agents that don't just run application, but also participate in governance itself. So that is really incredibly powerful and can be risky if an agent drifts from intent. Now, what safeguards do you have if an agent go off script?
See, I mean, before jumping into the safeguards, it's important to understand why is it a very natural progression. When we started building in this direction, we got a lot of questions initially. Are we there? Like, can we trust agents for governance? Humans are very lazy species, right? We are always looking for the birth of AI is a classic example of that. We want to do everything faster, and we want somebody else to do it, and we always want to keep on increasing our hourly rate. So we are always looking for efficient ways of getting the job done, and that has what has given birth to almost every technological innovation around us, to become efficient, to get things done faster, because we want to kind of really be as free as possible. Now, when we talk about on the same breath, when we talk about the whole agentic AI economy, what is it? Starting to trust a line of code to execute things that until yesterday we were not even trusting our parents to do for us, or our girlfriends and boyfriends, or our wives to do for us, right? So Why is that? Because we have started trusting, like Ethan at the beginning mentioned, right? And that was a very powerful statement. I have a conflicting response to it, but humans are more complicated than technology. That's if you read it black and white, it's a very interesting statement. Humans are complicated. Technology is binary, either this or that. So if you see technology that way, and you are creating that technology, you know till what extent it can go, to an extent, right? And then hence creating guardrails around it, it's still possible. Creating guardrails around humans may be very difficult, but creating guardrails around technology may still be possible. I'm just expanding on that statement, right? And I want to quote it again, Ethan, like brilliant statement when you say that. Now, having said that, number one, it is a need. Humans are going to want to rely on other piece of technology for practically everything going forward, from paying our bills to making phone calls. For us, I'm already using iPhone has started this thing. If you get a call from an unknown number, first the agent will speak to identify what the name is. I'll get a message that this person is calling, and then if I accept, only then I have to pick up the call. So it's already starting. Like agents are starting to answer phone calls for us. Tomorrow, they're going to start paying bills for us. Day after that, they're going to start managing portfolio for us. A beginning of that has again already happened. What is algorithmic trading? Implementation of AI in algorithmic trading is that you are trusting an agent to manage your money. So an algorithmic funds managed by AI, funds powered by AI, people are investing more in that, right? So the trust in machines and trust in AI is already starting to see a lot of uptick. If all of that is happening, isn't it absolutely natural that even in governance and even in terms of voting, we start trusting AI agents? That's going to be a very natural progression. And hence the need in the blockchain space where we call it trustless, we are actually trusting the code, right? So it's a very double-edged statement that blockchain is a trustless ecosystem. You're not trusting a private bank, or you're not trusting a private individual centralized authority, but you're trusting the code. So it's really in the age of machines, where now having established that machines and technology is going to be becoming a substantial part of our life, we are trusting those machines. So are we actually in a trustless ecosystem? To me, no. We are in the most trust-based economy now more than before, because earlier we were in a human-centric society, questioning whether or not we should trust tech. Now we are in a tech-centric society, trusting the tech. So that has moved even way beyond, if you will. And hence, in that case, when we are moving in that direction, these same agents who are taking financial decisions for us, who are answering phone calls for us, who are sending messages and emails for us, will also have enough data to understand our lifestyle and participate in governance on our behalf. We just have to build those models smarter initially to make sure that humans have that control. That, for example, I use the example of my telephone's agent first sending me a text that, okay, this person is calling, do you want to answer or no? If I click yes, I get the phone call. Same way in governance, initially there will be questions coming back to the humans after the agent doing a lot of due diligence. Click yes or no. There is I can't talk much about it, but there is a business development tool that we are making now, powered by AI, which is going to change the course of business development in the crypto industry. Every year, over $1.5 billion get wasted in the world of Web3 just in the name of business development. How do you make that efficient using AI is something that we are building now, and next month we'll make the announcement about it. So humans wanting to be efficient will lead naturally to humans wanting agents to be a part of our governance. And to protect that, two things. The second part of your question. Number one, if you can predict where technology can go, because it is binary, 0 or 1, it can't be more. Now, when we are, now we are moving towards the qubit age, where it's going to be much more dynamic, beautiful. Then it's going to be a different game altogether. But till then, when qubits are not powering AI, till then, it's going to be a much predictable journey. And second is security. Making sure that nobody else can get access to your code. Nobody else can break into your code. And that's where quantum security becomes the most important aspect of our human lives today. Because if somebody's sitting with a powerful system and you are trusting the line of code with everything practically possible that you have, and that powerful system gets access to that line of code, you're done. And hence building infrastructures which are practically uncrackable is the most important foundation of human civilization today. That's how we enable these two pieces. Because Quranium's entire mission is building this infrastructure that's practically uncrackable, even by a quantum computer.
All right. Thank you very much, Kapil. I'm going to direct this question to Alex because your stack talks about privacy and security, and governance also demand an adequate amount of transparency, right? So how do you think we can actually balance those two? Because how can the governance system stay transparent and auditable and without it exposing sensitive data strategies or votes?
Yeah. So the verifiability here is the key, right? The verifiability is the key. So if we're running an agent that's doing governance, and I actually fully agree with Kapil. And first, we should give them full autonomy, but still, if we're building an agent that does governance, its source code should be open and verifiable, meaning that whoever is running this agent cannot just silently change the source code without telling anyone, because then we are up for a disaster there, right? And that's what the confidential VMs actually provide, right? So you create your code, you deploy it, you prove to everyone that you're running this particular code. Now, in case you have a new, updated, better version of the code, it can be tied to meta governance, saying, okay, can we upgrade our, say, governance agent to this new version that does this and this and this? And then if the people agree, then the upgrade can happen. But it shouldn't be happening without that. And that's that's the key property, code being law. So and especially in this governance use case, everybody must be sure about which code is running behind whatever governance agents or whatever other agents that have access to critical information or can influence or make critical decisions. So as long as everybody agrees that the code is good, then they can work with those decisions. And if they want to upgrade the code, it also needs to be a consensus decision by everyone, all the stakeholders of that particular system. And then they can say, okay, now we want a better governance agent. Everybody agrees, yes, that the agent is upgraded to the new version. Very much like, like a blockchain stack, right? So whenever we want to upgrade Secret Network to a new version, there is a governance vote that people have to approve this new version, right? So I think it should work the same for governance agents or any important agents that influence a lot of people, for that matter.
Thank you very much, Alex. Ethan, are you in agreement with Alex's and Kapil's point, or you have a different opinion about it?
Largely in agreement with the one nuance I'll put on there that, part of why I said that about people is that I tend to think of everything that comes out of technology as ultimately being sourced by people creating or designing or building that technology. And it's more just different levels of, how deep you go for, a person being behind what's happening. Ultimately they're, the AI experts that are designing the AI systems or building those systems even. And they're doing some kind of steering, and that has some impact on what comes out of it. But yeah, otherwise, yeah, very much agree.
All right, thank you very much. Okay, so let's talk a little bit about enterprise because for all the cool demos, all the software and innovation, if a big organization don't buy in, adoption is still going to stay niche. And we know that enterprise are cautious by design because they've got there's the brand reputation, there's regulators on them every time, and they also have like money in the line. So the question is, what actually makes an organization comfortable enough to trust AI in the Web3 world? And Alex, I'm still going to push this one to you because your confidential AI approach, it feels tailored towards compliance-heavy industry where private has to stay, data has to stay private, and it still needs to move through the AI system. So do you see that as a way to win enterprise trust over by showing them that you're already thinking about the future threats?
Definitely. That is the way, and a lot, and I hear from my friends working in the enterprise world that big companies are explicitly prohibiting their employees to use things like OpenAI or any other systems. Think of a big Fortune 500 company that may be competing with some of the big tech giants. They don't want to share their data outside. That said, I think we as an industry still, at least from my standpoint, we still have a long way convincing Web 2 or traditional economy enterprises to embrace the world of blockchain. So I think our first stepping stone in this area is making Web3 enterprises use those confidential AI. And we already have big companies in Web3. So it takes time, convincing even them. But this is coming. And then, in my view, the Web 2 people will follow suit later, but it will take time just because the Web 2 world is still kind of wary and suspicious a little bit towards the Web3 technology. And to them, adopting Web3 based AI services would take a leap, I think, still would take a leap, at least for right now. But again, maybe the other panelists have other experience that would, and I hope so, would kind of disprove this point a little bit, or maybe take us closer to enterprise adoption, to real enterprise adoption.
Shai, do you want to comment on that?
Yeah, I could jump in here. I've spent quite a bit of my career working with enterprise, and I've found that there's really two particular things that will hold most enterprises back from really adopting any tech. It's really around complexity, and then the other one is really around risk, right? So how complex the solution is, how many pieces there are to it, how many partners are in the space, how new is it, how many integration points there are, right? The more of it that there are, the less likely they are to adopt it. It's like the more simpler the tech is and the easier that they can understand it, the more quickly they are to jump on the bandwagon. The other part is around risk. I just, maybe it's because I worked with a lot of financial sector and healthcare, but I find that a lot of enterprises, traditionally when they cross that mid-market stage, become enterprise, they're very risk adverse. If something works, they don't want to necessarily change it. And so that's ironically kind of the fundamental basics of a lot of the AI blockchain stuff that we're talking about. Is very complex. It is risky because it's new tech. There is a lot to learn and a lot of things to understand and a lot of controls that need to be put in place. And so that's, again, one of the things that I'm excited about the tech stack that we're building at Near, because when we look at things like Near Intents and cross-chain signatures, our aim is to make those very simplistic and very straightforward to use, but also auditable because they exist on chain. The attestations that you're driving those AI agents to do, right, whether they're executing inside a TE, as Alex was mentioning, or not, there is attestation and auditable records along the whole way through. And I think that's the key part that enterprises are looking for. They're not looking to manage the underlying gas fees. They're not looking to manage the underlying keys. They're not interested in understanding multi-step transactions and working across multiple chains. They really just want something that they can dictate their intent, that they can say, hey, I want to do this. I want to sign a specific contract, or I want to swap, and I want to pay my vendors in X currency at a certain time. They don't want to have to figure out all the multiple steps underneath that. They just want to figure out that part, right? And that's, again, where I'm very excited about the Intents architecture that we're building, because today is primarily an intent and solver network focused on the financial side. But we can very easily see this expanding into many different use cases, from decentralized marketplaces for consumer goods all the way to gig economy work, like a driving service, where agents come in and they're able to act as both that smart intent creator by taking the language that I use in my natural language and converting that into an actual intent that's actionable, and then on the other side having a solver network that is also led by AI agents that can then determine the best way to solve or come to a resolution for whatever it is that I asked for, whether it's a ride, whether it's vegetables or fruit. I mean, I think ultimately this is the simplicity that enterprises are looking for, because they're looking to reduce the error plane, right? The amount of errors that happen, whether they're human driven, whether they're driven in the code, right? I think there was mentioned before that everything that we do is ultimately driven by humans and created by humans, and so the enterprises are often looking for ways to mitigate their risk, and having agents that operate on a decentralized network has that auditable trace. They have the on-chain governance to manage the guardrails of what can and can't be done. I think that will start to bring in that comfort level into the enterprise that some of these enterprises are looking for, because it's going to simplify their on-chain experience, and it'll give them auditability and traceability when it comes to AI agents. And I think those are the two key parts that we need in order to see much more enterprise adoption.
Thank you very much, Shai. Speaking more on the intent, is it related to the concept of chain of abstraction from Near? Because I think that's also talking about lowering friction for users.
Yeah, and chain abstraction is, I think, a term that we throw around pretty easily, right? When it comes to wallets, when it comes to the user experience. I like to think of chain abstraction as really two simple things. One is the ability to do asset passing across multiple different chains. As a user, I should not care what chains I'm interacting on. My agents should not care what chains they're interacting on, right? And so I need to be able to pass assets and convert assets from whether it's Bitcoin to Solana, or Solana to Near, or Near to USDC or Zcash to Bitcoin, whatever it might be. I need to be able to do that asset passing in a secure way that relies on a decentralized MPC network, right? And that's a key part of chain abstraction, is getting away from the bridges that today depend on on-chain liquidity, have on-chain risk associated with them. And so that's one way, is through an asset passing bridge, which is what we call near intents. On the other side, you have something called cross-chain or cross-chain signatures, and that's the ability to be able to pass messages across multiple chains or any chains that I want to. And so if I have an action or an activity that is happening on chain A, maybe I want something to happen on chain B. Again, the typical use case that we see today is around the financial use case, being able to swap an asset and then deposit it in the liquidity pool. And so when you think of financial enterprises, that's the kind of simplicity that they're looking for. They want to be able to swap an asset and at the same time deposit that asset into a yield-bearing pool. And if that swap and deposit doesn't work, they want the entire transaction to be atomic and fail all the way through. And so that's the key part that we're building, is the on-chain in your intents, right? And then the cross-chain signatures. And then you have shade agents, which adds that cross-chain composability at an autonomous layer, which gives the AI agents the ability to interact with multiple chains and do that asset or message passing.
Right.
So multiple pieces there that make the final result.
Yeah, thank you very much. Okay, and speaking more on risk, we all know that compliance is probably the biggest headache that most organizations deal with right now, because the rule just changed in a split second. So, Ethan, do you think AI can actually help enterprise keep up with shifting regulations without them having to hire armies of compliance officers?
So it's a funny question. There's an inherent side of this, that just the existence of this as a technology means there's more paths for things to drift, leak, and go wrong. And if you go tell, a regulator or, that sort of thing, that you're using AI or critically depending on it, it's probably going to, make them be a little more worried about what you're doing as opposed to less. To me, the biggest piece of this is really guiding that conversation with them. It's, are you using an AI in some kind of reckless way, or are you using it to really add extra strength, extra defense and depth? Are you playing to its strengths and getting the value out of it to actually improve things, make them more efficient, make them more reliable overall? And the more that we can find those creative solutions or find those ways to leverage it in those kinds of areas, the more that folks over time are going to get more and more on board with it. And there's lots of examples of it. Whether you're talking about things specific to Web3, there's lots of problems like blind signing and malicious tokens and that sort of thing, and just like anomalous transactions and understanding what's going on there. We've seen over the years just too many places that have had problems in those kinds of areas. If AI can help more and more in that area, that's great. And it's not like it's going to be the only thing that's finding a problem. You can take it up a level, just to the blockchain ecosystem level, finding problems, thinking about, like abuses of like bridges and oracles and that sort of thing. Maybe AI is going to help have some improvements there over time. And it's probably not going to be in a super simplistic way. Maybe it will be. That's even better. And then you can take that into the compliance area also. Maybe AI can help speed up internal audits or external audits. Maybe it can actually help finding misconfigurations or prioritizing things. One of those areas, I don't like to think of it as it replaces anything else that's happening, but more if it can get me a better signal to noise ratio than what I'm looking at right now, or it can help with, if I've got, 50,000 vulnerabilities, maybe it's going to help me figure out which ones are best to look at. Those sorts of challenges, those are great. Those are the kinds I'd expect that folks on the outside, with the right side of kind of oversight, are really going to appreciate people doing with it.
All right. Thank you very much. Then another question I have is, because it seems we still have a couple of minutes. Agents won't live on one chain anymore, right? And as we know in Web3, you can trust your home chain all day, but the moment you bridge out, you're definitely depending on someone else's security. And we've seen how that goes in Web3. So how do we make cross-chain interaction or action safe, especially as AI agent is going to start moving from different ecosystem that has different trust model? Kapil, do you want to comment on this?
Yeah, I mean, just like now, after individual blockchains starting to capture the market, the whole multi-chain model is picking up. Every different ecosystem adding different value. The same will happen with agents as well. I don't see it any different. It's just a matter of time. Always, of course, some projects will have a preference to start with, but for any ecosystem to grow and for any project to grow, eventually the multi-chain capability is going to be the key. So I don't see that as any hindrance. It's going to be a very natural progression over the course of next 8 to 12 months. We'll start seeing a lot around it.
Ethan, do you want to comment on that?
Yeah, I tend to agree. There's certain strengths and weaknesses to AI, and just playing to the strengths of it, where you have some of these multi-chain sorts of challenges, and there's lots of them that are out there. Some of them are somewhat solved, some of them are totally unsolved and still painful. And it's just finding that and really evolving it over time.
Okay, thank you very much. Because I was thinking from a security point of view, AI might actually help us like standardize how chain communicate. But if you think about it on the long run, it also expands the attack surface, right? If, for example, different organizations have different standard and the standard are not rock solid. So I would say the real coordination only works when these different ecosystems have like shared security, not just like shared APIs, right? We have some shared security best practices that we both agree on, and we're following to make sure that both of our ecosystem are well secured before we actually allow that interaction happens. All right. Looking ahead, what do you see as the next big thing or the next breakthrough in the intersection of AI and Web3, Shai?
So actually, coincidentally, you were just kind of teasing it up a little bit there when you were talking about shared security, because actually when I think about the roadmap and I think about the future, we're going both on a technological level, but also on a socio-political and geopolitical level. I don't think that we really can have this assumption that there's going to be a shared security model or a shared trust or shared guarantee model with other chains that we work with, right? I think that we have to have the tech, and we have to build the tech in a way that is going to allow us to do things, for example, like give our agents a scoped set of permissions that says, Agent A, you are able to do these things and go do these things, right? Whatever those things are. Now, those things might not be allowed on the secret network, or they might not be allowed on a different chain, or they might not be allowed on Near or an Aurora-based chain. That's fine. So you can't do those transactions on that particular chain, whether it's a financial transaction, whether it's signing for a certificate, whether it's attesting for a decentralized ID, for whatever reason, right, that agent is not meeting the criteria of that particular chain. The other part, which we're going to see a lot more of, is something I like to refer to as path routing or path finding, right? It's a very much a human characteristic, and we were talking about before about how difficult it is to make AI behave like humans and mimic human behavior. Part of it is because of this intelligent path finding or route finding. It's not just about where there is the lowest gas fees. It's not just about where there's the most liquidity. It's also about what is your security trust model. So if you're a bank, for example, and you're interacting with AI agents and you're adopting AI for the enterprise, you're going to want to make sure that whatever other chains you're interacting with or other protocols you're interacting with are also meeting your security requirements and your security constraints and controls and measures and everything else that you have in place. And so I'm excited for this world where, and I think this is still a couple years out, where our AI agents will understand our security model as an enterprise or mid-market and be able to find the chains in the ecosystem that meet our security model, not because it's a shared model, but because we share an ideal vision of what security should look like, and it's more meeting the lowest trust barrier between those multiple chains. I think those are really the two key things there is, again, around the scope permissions and that pathfinding. The final one, I think, that is going to give us that security, which I think we're some time away from. I think we do a good job in Near with our pause and wait function, is the concept of an atomic execution, that one transaction should fail entirely if all the steps underneath it also, if any one of those steps underneath fail, we should be able to roll back the whole entire transaction and start over. And likewise, we should be able to see all those transactions as one atomic transaction, whether they occurred on chain, off chain, on a different chain. And so I think that's a key part of the underlying protocol level that the chain is responsible for, to give you that functionality of being able to atomize your transactions across multiple chains.
Thank you very much, Shai. Alex?
I'd like to make an addition here as well. So again, talking about verifiability, right? So with verifiability, essentially comes transparency, meaning that, you know, the source code, or, you know, more technically, the Docker Compose file from which the specific workload is actually built, is available to everyone, and through that, the source code as well. And that means that we could potentially build systems that would verify compliance of certain software packages to certain security standards, like is my confidential AI running the right version of Ollama, or is it even running, or maybe this particular ecosystem only wants to work with VLLMs, or you can choose to check all the dependencies that of my software or my software agent and see if any of them are not meeting the security standards. And with open source code and verifiability, this seems to be achievable in an automated way, especially if we're using AI. Of course, there's a lot of work to that. Ethan, I think you might have an answer, a counter argument to that.
Ethan?
Actually, not really even a counter argument. It's more the fundamental piece of this that's behind what both of you were just saying. Over time, finding ways to have AI make this simpler and more reliable. And there's so many dimensions it can go, and it's just, as long as it drifts in that direction or progresses in that direction, we're going to be on the right sort of path.
All right. Thank you very much, Ethan. All right, guys. What advice are you going to give somebody that is launching an AI and Web3 project like right now? Kapil, do you want to throw some word of wisdom?
I don't think I'm qualified enough to give an advice to somebody yet. But if I have to share my 2 cents, it will be like, don't listen to too much of advice. Just do whatever you're passionate about and go for it. That's all I would say.
Thank you very much.
I can jump in as well. I'll give a little bit of advice, but I do agree with Kapil a little bit as well too, right? Don't take my advice blindsided, right? You should always do your own research and own your own perspective. But I'll answer this from your perspective, right? If you're starting on chain and you're starting to build your AI and blockchain use case, I find that a lot of builders think of this as, okay, this is either an AI or this is blockchain, and if it's blockchain, later it'll come to AI. If it's AI, later it'll come to blockchain. I think that causes way too much stress and way too much of a headache. Think about the problem that you're trying to solve. Think about the AI agents that you're going to have that are going to be part of your architecture, and then try to scope the permissions of those agents as narrowly as you can. We just had a great discussion about security. I think this is often an area that's really missed from the very beginning, is the ability within Near to set your account based on that agent. So you can have, shy.near, and then you can have agent1.shy.near, agent2.shy.near, or any other permutation of that. I could then give my AI agent specific functionalities and permissions of what they can and can't do on chain. They can send transactions, they can swap transactions, they can execute this contract, they can't execute that contract. And so the more you can scaffold the agent and the permissions of the agent and think about that on-chain logic, the simpler you're going to make your application, because you're going to make that logic embedded on-chain, as opposed to playing this game of trying to figure out, okay, where do I put the logic? Is it on-chain? Is it in the agent? Is it somewhere in between? And then you just end up with a centralized solution again that all it's doing is leveraging the chain as a database, and that is pointless. Like, you're not really gaining any benefit of the underlying blockchain if it's just a database, right? So think of it as an execution layer, and how do you leverage things like the chain's permission set in order to make your agent more secure inherently? Once you do that, then I think you can have a much more structured approach to your application. But again, do your own homework and research, think through that, and you're going to hear lots of advice everywhere. You have to decide what makes sense for your startup.
Yeah, that makes sense. Thank you very much for that, Shai. So for those that wants to follow your work or get in touch, what's the best way to reach you guys, and what platform are you most active on? Ethan, let's go with you first.
Oh, sure. Easiest way, just reach out to me on LinkedIn.
Awesome. Shai?
LinkedIn, but also my URL is shy.fyi. So very easy domain. You can find my LinkedIn socials, everything on there. I generally most often on LinkedIn. And also follow the Near Telegram channels, and I'll give a shout out to Near Legion. If you want to be part of our community, you want to dig in and contact myself, the rest of the Near team, jump into nearlegion.com, and we'll see you online.
Thank you. Alex?
Yeah, for us, it's mostly Twitter and Telegram, less so LinkedIn, although LinkedIn also works. So these are the key platform me and our team are using, so that they are the best way to reach us.
Thank you. Kapil?
LinkedIn, X, Telegram, anywhere works.
All right, thank you very much. This has been an incredible conversation because we are able to cover a lot of ground today. We talked about security, privacy, enterprise adoption, and we even talk about the road ahead, what it might look like for AI and Web3. A huge thank you to our guests, Ethan, Alex, Shai, and Kapil. Thank you guys for not just joining us, but for sharing your thoughtful insights on how AI is evolving within the Web3 ecosystem. And I'm truly pleased to have hosted this amazing discussion, and big thanks to the Hacking team for making this opportunity possible. And of course, thank you to everybody that's tuned in. Conversations like these are actually the ones that shape the future of our space. That is how we build responsibly, how we scale securely, and also how we keep privacy at the heart of innovation. Until next time, stay safe, stay private, and keep building with security at the core. Thank you, guys.
Thank you,
Thank you.
Steven.
Bye-bye.
Thanks, everyone.
Thank you as well.
Great stuff.
Everybody.
Thank you.